All right, so for today, on to chapter 3. A nice little polynomial, right? Polynomial. Right? Now, draw me the graph of that. No. Okay. Actually, if you had a graphing calculator, computer, it wouldn't be all that hard. You could do it. Graphing it by hand, that would be a whole other story. Okay, go this way. But, right? So this is a polynomial. So first off, in regards to this polynomial, I want to know what degree is this polynomial. Well, that's easy enough. What's the highest number exponent you see? 5. A 5. So it is of degree 5. Right? Just find the biggest exponent. That tells you what degree it is. Right? All right. What is the leading coefficient? 6 is correct. So you find the biggest exponent, which was the 5, which was the x to the 5th, and then you find what is the number in front of that x. And that number is a 6. Tricky stuff, right? Easy to forget, right? All right, so this is a 5th degree polynomial. Okay. And the exponent, the coefficient in front of that x to the 5 term is a 6. All right. So, given an equation, given a polynomial, you ought to be able to tell me what degree is it and what's that coefficient. And again, not too hard. Look at it, find the biggest numbers, and there you go. All right. Now, in terms of graphs, let's see. Well, if something was linear, which is basically what we did in terms of last week's stuff, right? We said a linear graph, whatever, depending on what it is, will look something like that, right? That's linear. There'll be some variation on that for a linear graph. Right? Well, how about a quadratic graph? Well, what would that look like? That's a U, right? So a quadratic has the U shape. And basically all quadratics roughly are going to have basically the same shape. It just could go up faster, slower, but they all have that same basic U type shape, right? So that would be true for x squared. How about x to the 4th? It would also have a U shape. X to the 6th would also be U. Okay? Right. So anything valued in terms of that even exponent will have that same basic shape. Right? And then the next one is a cubic function. And so for cubics, the basic shape is going to be like that. And you can figure it out, really you just come up with a bunch of points, okay? And you would get that shape if you plot it. So linear, quadratic, cubic. So I get this graph, whether it's x squared, x to the fourth, x to the sixth. I'll get this shape for x cubed. I'll get this shape for x to the fifth, x to the seventh, and so on. Okay? The only difference would be how quickly they would be going up. Okay? In terms of that. Okay? But in terms of the basic shape of the graph, you get something that will look like that. So in terms of an equation then, let's say I have in terms of my equation here's my equation. Okay? I want to know what's going on with my graph when I get to the outer edges of the graph. Okay? So what I want to know is what is the end behavior. As x goes to infinity, what's going on with my graph? When x goes to negative infinity, what is going on with my graph? So when x goes to infinity, what's the value of y going to be taking on? Infinity, right? There will be infinity, right? After all, as x goes to infinity, none of these other terms matter when x is really large, right? So when x goes to infinity, this will be going to infinity, right? How about as x goes towards negative infinity?
Does it go to negative infinity?
Nope, it won't be negative infinity. It'll be what? Infinity.
Yeah.
Because after all, this is x to the fourth, right? If you take a negative number, you raise it to an even exponent, you end up with a positive number. Okay.
Infinity would be considered a number still?
And beyond.
Beyond.
Okay. Right? So now that's what's going on at the ends, the outer fringes of my graph. Right? It's taking off in terms of infinity. Okay? And again, that matches basically what we said on my graph over here, because we said for quadratics and any variation thereof, that the ends are going to be the same sign. Right? So these two are going to match. If it's a cubic, however, like if I went down here, then at the ends, you got one will be going to negative, the other one's going to be going to positive. Right? At the ends. Right? So, for example, right, we had something like this. And again, I want to know what is the end behavior. Again, so I want to know what happens when x goes to infinity, and what happens when x goes to negative infinity. Well, if x goes to infinity, where's my graph heading up to? It's going to infinity, right? It's going to infinity. Right? All the other terms disappear when x gets really, really large. Okay? They are important when x is small, right? But once x gets big, they don't matter. Right? How about as x goes to negative infinity? Where are we heading? We're going towards negative infinity.
This is for cubic, right?
Wait, why did that change from the first one to that one?
Well, because now I got a negative number raised to an odd exponent.
So you're only paying attention to the very first.
The largest exponent, yep.
That's all you pay attention to?
Yep. Okay? Because again, we're talking x is really, really big. Okay? Right. Right. Okay? So when x is really, really large, all the other terms are nothing compared to that term. Okay? All right. So, for example, in terms of what we're talking about for this, all right? All right. So here I got 7x to the 7th, right? Let's say, for example, this is how you can see heavily what happens here with this. Let's say that x is 10 to the 9th. Right? Well, what is 10 to the 9th raised to the 7th power? 10 to the 9th raised to the 7th becomes 10 to the 63rd, right? Remember, whenever you got a power to a power, you multiply, right? Well, what is 10 to the 9th raised to the 4th power? 10 to the 36. Yeah, that number is large by itself. But if I compare this number to that number, this is nothing, right? Okay. Yes? Okay. So again, once we're heading out towards infinity, all the other exponents contribute nothing. It's only that biggest one comes into play. Okay? So, given an equation, you ought to be able to tell what's going on in terms of what's happening when you get to the end. Okay? Yeah. If it's an even exponent, they're going to match. If it's an odd exponent, they're going to be opposite. Okay?
Will an infinity cancel out a negative infinity? Like if they were together, would it just disappear?
No. We're talking about the graph. We're saying as I go out this way on the x-axis, this is taking off this way. When I go this way, it's going down that way.
Yeah, that was a bit off topic. I was just a question about.
But if we're talking about matter and antimatter,
Yeah, maybe it was a philosophical question.
So it's basically just talking about direction. Right?
we're just talking about what way is the graph going.
They're going the same way,
Yeah.
they're going different ways.
Yeah.
Because infinity is a number, but it hasn't been defined as a particular
Right.
number. I just didn't know, like, if they just came with, like any other, like a -1 would cancel one.
Yeah. Okay. Right. Right. So we can tell what's going on with that graph at the edges. when we are heading out to the far edges, right? Well, in terms of a graph, let's do one a little easier. Let's say I had something like this. That'll be a quadratic, right? If I multiply it out. Everybody remembers FOIL method? First, outer, inner, last. We should be able to multiply that. But that'll be a quadratic, okay? If I do this out in terms of that whole FOIL method, you will end up with an x squared plus 2x minus 8 if you do it. Okay. Well, I want to get an idea of what's going on with the graph here. Okay. Well, first off, x-intercepts.
Infinity to negative infinity.
So what is an x-intercept? What happens at the x-intercept? What is an x-intercept? It's where it crosses the x-axis, right? And when it crosses the x-axis, what is the value of the y-coordinate? 0, right? So at the x-intercept, right? At the x-intercept, you have that y will equal 0, right? So we got 0 is going to equal x plus 4 times x minus 2, right? So that says that this times this gives you 0. How do you get 0 when you multiply?
Times
If one of the numbers is 0, right? Which means that either the x plus 4 has to equal 0 or the x minus 2 has to equal 0. And then I can solve each one of these for x. So this one will give you x equals a minus 4. And this one will be x equals 2. Right? Everybody's fine with that?
Is that because you're just trying to get the x by itself?
Yep, solving for x. Right? So by putting the little steps here, it'll be minus 4, minus 4. This will be plus 2. Right? Okay. All right, so let's go to a new page and let's plug in that information that we just got. All right, let's. So we said negative 4. So there's that, and there's that. All right, we got those two. X-intercepts. Easy enough. All right, let's go back to our equation. Next thing, y-intercept. What is true at the y-intercept? It crosses the y-axis, and what else is true? In terms of the coordinates of that point, what's true?
Equals 0.
What is equal to 0?
Y.
Not the y, the x.
Or the other.
Right? At the y-intercept, x is going to equal 0. Okay? So at the y-intercept, we've got that the x is going to equal 0. Okay? And so for this, let's actually look at this form of my equation. We had that y equals x squared plus 2x minus 8. Well, what's the y-intercept? Negative 8, right? Just replace the x with 0. Only thing left is that constant term. Right? So I know the y-intercept is going to be -8. So let's plot that on our graph. There's that point. Okay. So we have 3 points on our graph so far. So now we need to know what happens everywhere else in between. So let's go back to our page. Go back here. In terms of my x-intercepts, we said -4 and 2. Let's call that -4. Let's call that 2. My terms were x plus 4 So now we're going to figure out what's happening with my graph. Is it positive or is it negative? All right, so first off, if x is less than -4, right? If it helps, pick a number that is less than -4. So for example, let's take -10. If x is -10, x plus 4 will be positive or negative? What? It'll be negative, right? This will be negative. X minus 2, positive or negative? Will be negative, right? What's a negative times a negative? Positive. All right. If x is a number in between -4 and 2, so let's pick the easiest number that's in that range, which is 0. Well, what's the sign of this going to be? Well, what's the sign? Be positive, right? I don't care what the number is. Right? What about x minus 2? Positive or negative? It'll be negative. A positive times a negative is a negative. And then lastly, if x is greater than 2, x plus 4 will be?
4.
Well,
Where's the positive?
just sign. I don't worry about
Positive.
All right. X minus 2 will be positive. And then a positive times a positive is a positive, right? So what I know is that as I come in from negative infinity, right, up to -4, my graph is increasing. Okay. It has a positive slope. Okay? From -4 to 2, my graph is decreasing. Okay? And then from 2 to infinity, it's increasing. Okay? Positive, right? Right? So, actually, I can replace this. Sorry. Let's go back here. All right. And go here, right? So, from negative infinity to -4, this is going to be above the x-axis. This will be below the x-axis. And then this will be above the x-axis, okay? That way it's telling you the sign on the number, right? So it's above, then it dips below the axis, and then it goes back above, right? So if I do a rough graph of what's going on here then, we would say, okay, so here it's coming down from here. It's going to cut my point there, maybe, given my drawing ability. It's going to go down somewhere, hits that point, and then it's going to take off, okay? Like that. Okay. Right. Right. We get something that was right. Well, we can actually find out a bit more about this than this rough approximation. We can fine-tune it. Right? So we can fine-tune our graph. Because in a quadratic, whatever it is, if I have a quadratic graph, whatever it is, something like this point down here is called the vertex. Whether it's down there or top of that. The bottom of that curve or the top of the curve, depending on which way your quadratic is going, that's the vertex. The x-coordinate of this will be given by minus b over 2a. So let's see, mine was x squared 2x minus 8. Yep. That was my graph. Okay? My general quadratic is this. Okay? So A is the number in front of the x squared term. B is the number in front of the x. C is the constant term. So in this case, A is 1. B is 2, C is negative 8. So for my vertex then, for the x-coordinate, that'll be given by negative 2 over 2 times 1. We set it up on the previous page, and the vertex was given by minus b over 2a. So this is going to be minus 2 over 2, which will be minus 1. Okay. Well, what about the y-coordinate? Well, that's easy enough. Get the y-coordinate. We take that x number we just got, and we plug it in. So my y-coordinate will be given by minus 1 squared 2 times a minus 1 minus 8. Minus 1 squared is 1. So we end up with 1 minus 2 minus 8.
Oh, you just dumped it.
I just dumped it in.
Okay,
Yeah.
sorry, I was writing down the vertex stuff.
And that'll give us a y-coordinate of minus 9. So that would be the coordinates of the bottom of that curve. Okay? And so we can also get that point and plug it in to my graph. Okay? Yes?
But didn't we already figure out, like, the vortex in the first place? Because it's -8, like it's on the graph.
No, that is the intercept. That's not the vertex.
So that's not the lowest point.
So now if I go back and I sort of fine-tune my graph a bit, I should, now that I know what my vertex is, and I decide to fine-tune this a bit, right? So let's... So I know the y-intercept was here, and I now know that the vertex point is over here. So I know it comes down, it's going to hit this point. At that point, that is when it decides to go back off. Okay? So that tells me where the turnaround point is for my quadratic. Okay?
How do you find the y coordinate? Sorry.
For that?
Yeah.
All right. All right. So let me go back to here. So here, this is how I got the x, right? So all I got to do now is take this number, plug it in. So -1 squared,
Oh,
2 times -1. All I did is just take the x number, plug it in, see what you get.
gotcha.
That'll give you the y. And then I can plot that information, right? So given a quadratic like this, okay, not anything bigger, but maybe given a quadratic, you should be able to tell what's going on in terms of, quickly coming up with a rough graph of what's happening. Okay. You can plot the x-intercepts, you can plot the y-intercept, and you can find the coordinates of the vertex. And then using that chart, decide if it's above the axis or below the axis. And get an idea of what's happening.
The chart with the line -4.
Right, yeah. And then the plus meant it was above, the negative meant it was below. Okay. Okay. Any question on that first part?
Go over that chart again.
Back to my chart?
Yeah.
All right. Which was that picture. All right.
Yeah.
All right. So these are my numbers for my x-intercepts, right? Okay. And then I want to know is what happened when I go from -infinity to -4, from -4 to 2, from 2 to infinity, right? So again, if you think in terms of my terms here, so if x is less than -4, so if it helps, pick a number. And again, all I'm worried about is what is the sign on that number. I'm not worried about what the number is. I just want to know, is it going to be positive or is it going to be negative, right? So if x is less than -4, then this will be negative. This will be negative. Okay? And then we said that y is given by this times this. So a negative number times a negative number will give you a positive number. Okay? And that if x is a number in between these two, and we said if you need to pick a number, you go for the obvious choice, which is make x is 0. Well, then this is positive. This will be negative. And a positive times a negative is a negative. And then if x is greater than 2, everything is positive. So a positive here tells you you're above the axis, a negative tells you you dipped below the axis. Okay. And we can make use of that information and come up with our graph. Okay. Any other questions? Let's see, with that, let's take a break. So about a 12-minute break. So quarter of, by that clock. Hi. So in terms of a quadratic, so like the one we just did, another way I can write that equation is in this form. F of x equals a in parentheses x minus h quantity squared plus k, right?
That's the equivalent of the.
Well, it would be, I could take, yeah, the one I had and rewrite it. I could get something that looks like this.
So, what was it?
ax squared plus bx plus c. Okay. So now, in this form, however, when the quadratic is written this way, you got that hk tell you the vertex. Okay. Right. A tells you basically in terms of how fast it's increasing. So like if A is a number like 5, you think about a quadratic is that U shape. Okay? So as A gets larger, what happens to the U shape? Skinnier. Right? So as A gets larger, larger positive number, that U shape gets skinnier and skinnier and skinnier. Right? What about if A is a number in between 0 and 1? What happens to the U? So if A is a fraction, what happens to the U shape? Right, it flattens it out. Okay. We got that? All right. So if A is greater than 1, right? You got that the U shape gets skinnier. All right? It's going to go up faster. Okay?
It's going up faster.
Yeah. So, for example, if I graph just x squared graph, roughly it looks like that, right? This is y equals x squared, right? If I graph y equals 10x squared, what happens? Well, if I graph y equals 10x squared, the graph is going to look like that. Right?
I don't understand why there's something about this that's just completely
All right.
over my head.
So let's do it this way. Let's first do my basic quadratic. -2, -1, 0, 1, 2, right? -2 squared is 4a. So my numbers here are going to be 4, 1, 0, 1, 4, right?
Right.
All right. Let's do the blue graph. In the blue graph, I said it's going to be y equals 10x squared, right? So now I want to do the chart for that one. Well, for y equals 10x squared, and again, if I do the same numbers, -2, -1, 0, 1, 2, well, what's -2 squared? What's 4 times 10? 40. Right? This will be 10, this will be 0, this will be 1, and that'll be 40, right? So now it's going to be over 2 of 40,
Okay,
right?
okay.
Right? So if A is larger than 1, the U shape gets narrowed in. Okay? If A is a fractional number, then the U gets flattened out. Okay? So if A is less than 1 and but greater than 0, then the U shape gets wider. So that would be if I did this. So now this is going to be the graph y equals 1/10 x squared. Okay? It's going to flatten the curve out. Okay?
What does that say about if something?
If A is between 0 and 1.
Oh, okay.
Because actually if it's 0, we don't have anything, right? Okay. All right? So the A badly tells you in terms of how quickly my quadratic is increasing, right? In terms of the curve. Here's an idea of what's going on, right? So now, given a regular quadratic equation, how do I change it from that form into this form? Right? So, for example, everybody got all that before I change the page? Right? So, for example, let's say we have this equation. Y equals that's my equation. General way, all right? I want to change it into that other form. Okay. Well, we said that the h earlier, and we did this earlier, we said h was given by minus b over 2a. So in this case, in terms of this, for this particular one, we got that A is 3, B is -7, and C is 2. So I can plug those into here. So in terms of H, we got H will be minus the -7 over 2 times 3. That'll give me 7 over 6. Okay. I know 2 negatives in a row makes it a positive, right? Okay. Now the K. The K will be given by that. So we can find the K value by doing this. So for this one then, we got K is going to be 2 minus -7 squared over 4 times 3. So now it's a matter of number crunching that part out. So this will be 2 -7 squared is going to be 49 over 12. Well, we have fractions, and everybody in here loves fractions, right?
Those are my favorite.
So in order to add a that fraction, we need to have a common denominator. which in this case will be what? 12 is correct. So this will be 24/12 minus 49/12, which will be minus 25. 12. Right? Right? So we said my format that I'm looking for is that f of x is equal to a x minus h squared plus k, right? So we know the h, we know the k. That leaves the a part to figure out. Okay? Well, what is the a? The a is the 3. After all, you can just read it off of my equation. And so we have everything we need. Right. My h, we said was 7/6. And my k is that. And that is my equation in the other form.
That's a 25, not a 2.5.
That is a 25, yes. There. Your little skip in the pen. Okay? Right? So we changed it from the usual standard form of quadratic into this vertex form of quadratic. Does this quadratic open up or open down? Good question, right? Let's go back to the top. Does it open up or open down?
Open up.
Open up. You can tell that easily enough. Look at the number in front of the x squared. If the x squared term is positive, it opens up. If the x squared term is negative, it opens down. Okay? So the sign will tell you if it opens up, opens down. Okay? Right? So that would mean that in terms of like next week's quiz, and after all, in case you don't know, there will be a quiz next week.
Is there a quiz every week?
There is a quiz every week, except for the final, right?
Except for the final.
Right. So, Billy, if I gave you something like this, I give you that equation. And I asked in the question, what is the coordinates of the vertex point? You ought to be able to tell me. Right. So the coordinates of the vertex will be to just read it right off the equation. Right? Actually, I'm sorry. And sorry, except for this will be a minus 3 halves.
What's the minus? I thought it
Why
was
won't it? Fine.
Oh no, it's minus h.
Right? And why? Because my format, where did I put it?
Right, it's plus k.
Right here. Here's the format, right? It was a minus h, right? which means in order for it to be a positive number, meant that h itself had to have been a negative number, right? That way, minus to minus made it a plus, okay? Right? So, given an equation like that, you know, again, you should be able to read off the equation and tell me what's the vertex, okay?
It wouldn't be,
So,
And I'm sorry, what, can you go back?
wouldn't it also be minus 8/3?
Yeah.
Plus k?
Yep, minus 8/3. Just check my equation there. There we go.
Because there's a negative in front of that grouping with the 3 over
Well, that
3.
just tells me that this parabola will do what? Open up or down?
Go down.
This parabola will go down.
Because the 6 is negative.
Okay. So basically ignoring those, and finding out the vertex, ignoring everything else except for what's in the fraction.
So this question, wait, but you don't want to know what's the vertex, okay? And again, it works out because of the way my original equation was defined. We said it was given by this. Okay? That's the original format. Okay?
I thought it was plus k.
Oh, sorry. Yeah, my, there we go. Read my, okay? Here's my format, which I had a couple pages back, right? So in order for this to be a plus, okay? In order for that to be a plus means that h itself had to be a negative, okay? And because this is a minus 8/3, k will be the minus 8/3, okay? All right. And again, so that's the vertex, and again, this parabola is opening downwards. And again, you tell that by the number up front. All right.
The H and K, they're just actually just any variable. It could be like they,
Well, h and k are the coordinates of the vertex.
Okay, but those are just the
That's the designation. The h is the x coordinate. The k will be the y coordinate of the vertex.
You said K was Y.
The will be the y coordinate. Yes. Okay. All right. So, for example, then. Everybody take a few moments and convert that one into the other formula. B, and C. That's all we need to work on that. From there, we can get the H and the K.
So once we find the A, B, and C, then we can throw it into that K.
Right, the H and K. So you get your quadratic. First thing you want to do is figure out the A, the B, and the C. Okay? Again, the A is the number in front of the x squared term. If there's no number there, then that number is a 1. Okay? The B is the number in front of the x term, and then the C is my constant term. Right? Right? So the first thing you do is you figure out the A, the B, and the C. Right? Right? And then, if you cannot figure out the A, the B, and the C, that is when you end up with the D or the F. Alright. Okay. So in this case, A is 1, B is -8, and C will be 3. So now I'm going to take those numbers and plug them in here. And I can calculate the value of H, the value of K.
So what you get to 2A?
That's just the formula.
That's the formula.
Oh, okay, it's the formula.
Right. So my H is going to be a minus 8 over 2 times 1. And that comes out to be 4. Everybody got 4, right? Haley? All right. Okay.
So far, so good.
So far, so good. All right. Now we want to get the value of K. So this is going to be 3 minus the minus 8 squared over 4 times 1. So this is going to be 3 negative 8 squared is 64. And over 4. What is 64 divided by 4? 16. And so this will give you negative 13. Okay. Got that number, Haley?
I got a positive 13.
Because negative 8 squared is a positive 64. Okay. Did you have the minus and the minus becoming the positive afterward?
That's a negative 13 right there.
That's a negative 13. Because this will end up being 3 minus 16. Okay? All right? All right. So we have the H, we have the K, we know what A is. And again, my equation is in the form of f of x equals A x minus h squared plus k. So now I take my numbers and I plug them in, A is what? 1. So f of x is going to equal my h value, which was 4, and my k value, which is not. Right? We do not need the 1 out front, right? Because after all, 1 times anything is anything. Yes?
If x is 1 in those previous equations, then why is x still x right there?
No, the A is 1.
Yeah, but then you wrote out the equation like x squared plus x or something like that, and you said that the x is 1.
Okay. If I expand this out, we'll probably end up where we were. Okay? Alright. There'll still be a 1 in front of the x squared here if I do this out. Well, method. There'll still be a 1 in front of that x squared when I expand it out.
I'm saying, is that x, is that 1?
Is what 1?
The x.
No. The x, basically this is an equation, so x can be any number here. Right? This is an equation that will give me a graph. Right? So, given an equation in standard form, okay, so basically given something like this here, you ought to be able to rearrange it into the other form. Okay?
And what's that form called again?
It's a vertex form.
So the vertex would be 4, negative 13.
Negative 13. Yep.
Positive 4.
Positive 4. Right? Right?
And then what's the fx, that last equation that we just did?
So basically, we went from the standard way you see your quadratic, okay, into the vertex form of writing the quadratic. Because from this, I can read right off of here what is the vertex, right? The vertex is 4, negative 13. I get that directly from the equation. Okay? Right? And in this case, does parabola open, does the quadratic open up or down? Up. And again, because the number out front was a positive 1, it opens up. All right. Well, how about given something like this? So what is the end behavior if you got something that's now given to you in this form? So as x goes to infinity, this is heading where? Infinity. Okay? How about negative infinity? It's also going to be infinity in this case. Every one in my parentheses contains the x term, right? Right? I have an x term here, I have an x term here, I have an x term here. What is the exponent on this one? It's a 1. What's the exponent here? Where's the exponent there? What is 1 plus 3 plus 2? 6. So if I actually multiply all of this out, okay, if I did all that work, I would end up with a term that is x to the 6. Okay? Will be the biggest exponent on it, okay?
Wait, so if it's quadratic, you have to add all of those up?
No, that's not what it.
Oh.
So if I give you something like this and I ask you what's going on in terms of the end behavior, basically I need to add the exponents up.
What?
I add up the exponents.
Yeah.
That means that if I actually multiplied all this out, I would end up with an x to the 6th term. If I did it, okay? Well, if this is x to the 6th, then I know when x goes to infinity, x goes to negative infinity, both of these are heading off to infinity, okay?
So, is positive exponent?
The exponent would be positive, yes.
If it was a negative exponent, it would be going into negative infinity?
No, because it's not what a negative exponent means.
Oh,
If it's a negative coefficient?
But
It was
if there were the
un-
negative numbers in there, right?
If it was odd, would it be going?
Odd, remember for an odd,
Yeah.
the
then it would be
behavior
negative.
switches.
So if that was like x to the 7th, it would be negative infinity.
Right, for the bottom, yes.
So if you have it like that, just add all the exponents and then whatever number it is.
Right. Go from there. Okay? Yeah. Again, even exponents, the end behaviors are going to match up. Odd exponents, they're opposites. One will go up, one will go down. Even exponents, either both up or both down. Okay?
So you're just determining the degree of that term.
Right, really, just, yeah.
That expression.
Yeah. Just need to know what is that, what's the biggest exponent going to be if I actually multiplied it all out. Which you don't want to do. Okay? Right. But all you got to do here is just add the exponents up, and that'll tell me what's happening. Okay? Now, how about giving out something like this? I want to write out the equation that matches the following information. So, let's say the degree will be 3. Oh, let's see, the x-intercepts will be -5, -2, 7. The y-intercept will be, let's make this good numbers in, right? Now I want to come up with a polynomial that will match this. Well, we're going to be able to do it in just a few moments because this is all right. So, given that it is in degree 3, my equation will be in this form. Let's do different letters here. given that it's a degree 3, it'll be something in that form. Okay? Again, A tells you how quickly it opens or closes. That's what the A. We'll talk about how we do that. And then X minus L, and I just picked different letters because I didn't want to use letters we've been using here. But basically the L, the M, and the N, they basically correspond to my intercepts. Is what they correspond to. So basically we could say that this is the L, this is the M, and then let's say that is the N. Right?
There's an L.
That's an L, that's an M, that's an N.
Okay.
All right? So let's take that information that we have and let's plug it in. So now we get, my equation is going to be y equals A. This will be x minus a minus 5. But what happens when you get minus a minus? It becomes a plus, right? So that'll become x plus 5. And then, of course, the next one will be x minus a minus 2, which means that'll become x plus 2. And then the last one will be x minus 5. Right? Right? Everybody fine with that part? All right. Now we need to find A. The way we find A is now by making use of the y-intercept. Okay? So we can find A by making use of the y-intercept. Okay? So at the y-intercept, we have that x is going to equal 0, and y I had up there was 4. Right? Because at the y-intercept, the x value is always 0. Okay? So now I can take these numbers and plug them in. So we're going to get 4 is going to equal A. 0 plus 5. 0 plus 2, 0 minus 7. So this is just going to be 5 times 2 times a minus 7. Well, 5 times 2 times minus 7. Negative 70, right? So 4 is going to equal negative 70A, right? Opposite of multiplying? Divide. Well, 4 over 70, that can be reduced. It's not going to be a nice decimal, so we're going to leave it as a fraction.
We can have the fraction.
So what we get?
Negative 2/35.
Right, 2/35. Okay? Again, it's not going to be a nice decimal. And if it's not going to give you a nice decimal, we want to leave it in fractional form. You know, if it came out to be a half, yeah, you could write it as 0.5. Okay? Because that does become a nice terminating decimal number. Okay? So that would mean that in terms of my question, which was what is the equation that goes with it, the final answer is going to be y equals minus 2 35ths, and then it's going to be x plus 5, x plus 2, and x minus 7. And that would be the equation in terms of a third degree polynomial that matches that information. Any questions about that process? No. So with that then, there is one last thing for the day. Again, there is a guest speaker this afternoon, downstairs.
Do you know how long he's speaking for?
Roughly an hour, probably otherwise.
It's over with this.
What?
Get started on this.
Am I not gonna go?
Again, starts at 4:30, so right at the end of this class time. Downstairs, room 632.
10 a.m.
So again, when you're done with this,
And some notes.
are we done for the day?
Oh, that's it.